Alright, so question 9 from the Poisson exercise, 25G. The random variable y has a Poisson distribution with a mean of m and satisfies probability of y equaling 3 is equal to the probability that y equals 1 plus 2 times the probability that y equals 2. What are we going to need for this one? We're going to need our definition. So probability x equals x, which is in this case y, but that's okay, this is just our rule. Now what is it? It's m to the power of x e to the negative m over x factorial. So, if we're going to fill in the blanks using this, with a mean m, and we're starting off with x equaling 3, so therefore, we're going to have m to the power of 3, e to the negative m over 3 factorial, is equal to m e to the negative m over 1 factorial, which of course is just 1, plus 2 times m squared e to the negative m over 2 factorial. Well, a few things are going to cancel here. It's not going to be too bad, is it? First thing you can see is e to the negative m is a common factor. It's on all sides in every term. So if I just multiplied by 1 over e to the m, sorry, e to the negative m, careful with the way I speak, then they're all going to cancel, aren't they? Those e to the negative m terms will each cancel, which is great. I could have just multiplied by e to the m and that would have got rid of them. Same thing. Alright, what about our denominators? This one's over 6, this one's over 1, and here I've got 2 factorials too, so they're going to cancel anyway. So really I've just got a factor of 6 in the denominator there. I'm going to multiply the whole lot by 6. That's going to get rid of my denominators all at once as well. So, what do I end up with then? On the left-hand side, I've just got m cubed, and I've got 6m plus 6m squared. Well, this isn't too bad, is it? We can solve this one. It's not going to be terribly hard. What are we going to do? We're going to have m equals 0. My cursor's gone. Oh, look, there's the equals. That's not too bad. Equivalent sign. Now, remember, solving any polynomial, set it equal to 0 and factorise. So I'm going to have m cubed minus 6m squared minus 6m. Yes, I could have put them on the left, but I'd already started that way, so that's what we're going with. 0 equals m outside of m squared, take 6m, take 6. Not one that's going to factorise particularly nicely, so we're going to need our calculator. You could have just used your calculator way back here and graphed it. So let's do it both ways and see if we get the right answers. So let's start off by sketching our graph. Why not? And so let's go with this nice easy one. So we've got x outside of x squared, take 6x, take 6. So just a bit lazy, can't be bothered writing x squared. That's another way to do it. Draw. There we've got our values. One intercept there, one intercept there. Should be expecting a third intercept somewhere. This is a cubic. Might need to change our viewing window a little bit. Let's just zoom out. Let's go to our standard window, see if that helps at all. And there we go, we've got it. So you knew it was a cubic. You knew there would have to be one more. Shift G solve. What's the value of the roots? What are the values of the roots? Negative 0.87 can't be our value. 0, not our value for this one either. So it's got to be the last one. 6.87. So we've got, from our calculator, m equals 6.87. And of course, that's approximately equal to 6.87. Could have done it using our brain. So this is from our calculator, and you could include a sketch, or you can just say you use the solver. Some reason it didn't like the C there. So using calculator, we've got our answer. If you wanted to, a quick sketch, maybe not randomly drawn across the page, but somewhere here, and label that point 6.87, and that would be good enough to get you there. If you want to find the exact answer, of course, we can go ahead and use our quadratic formula. So we've got m equals 0, which we're going to reject because we can't have that, or m equals negative b, so negative 6 plus or minus square root b squared, so negative 6 squared, minus 4 by a by c is negative 6, all divided by 2a. And what are we going to have? Negative 6 just becomes 6. plus or minus, we've got 36 plus 24 is 60. 6 plus root 60 over 2. Root 60, of course, you can see that 4 is a factor of that. And 4 is a perfect square, so root 60 I could rewrite as root 4 by root 15, which is just 2 root 15. And now you can see the 2 is going to cancel. So we've got 3 plus or minus root 15 as the other possible answers. And therefore, the exact answer that we require in this one is, of course, the positive value of m. So m equals 3 plus root 15. And you can even justify your answer since m must be greater than 0. And there you go, you've gone ahead and found it that way too. All right, one to go from this exercise. Hopefully Poisson is getting a little bit easier for you now. Oh, what am I doing? I'm getting excited. It's getting a little bit easier. But not if we don't finish off the questions. Once we've got m, we've got to do the rest of it. Probability between 1 and 5. Let's go ahead and do that one. I'm going to take a little snippet of that and move it down because we're going to run out of room there. So let's scroll down a little bit. Here's our part B again. Paste it in there. And we just need that 3 plus root 15 will cover us there. So probability, so let's do B part 1. Probability y is between 1 and 5. So I'm going to need Poisson cumulative distribution up to 5, so less than 5, so that's actually up to 4. And I'm going to have to subtract the Poisson cumulative distribution. And it's got to be greater than 1, so I've got to subtract up to and including 1. So if it's less than 5, that means 0 or 1 or 2 or 3 or 4. Greater than 1 means it's got to be bigger than 1. So 2 or 3 or 4 would be the only ones left over there that we could use. I could just use my list and find 2, 3 and 4 and add them together. Or I can use this method. Either one would work fine. Let's go for stat Poisson distribution. Cumulative distribution, we're going back to a variable. I could have used the list, I already had it there. And I want to know up to and including 4 when our expected number, what was it again? 3 plus root 15. 3 plus root 15. We go ahead and work that out. Calculate that. 0.1849 approximately. 0.1849 minus the probability of up to and including 1. Just go back and change that 4 to a 1. Calculate that one. 0.0082. You can see the 3 decimal places that it was moved there. So 1849 minus 49 from that, we've got 32 left, 33 left over. So 0.1767 should give me the right amount. Let's assume I can do my maths. If I haven't got it right, I'm sorry. You can check it on your calculator. That's the answer. Let's go on to part B. So we've got the probability that y is greater than or equal to 2 and less than or equal to 6. Given that, conditional probability, given that y is greater than or equal to 4. So if I know it's greater than or equal to 4, I'm only really interested in the values bigger than 4 to begin with. Well, let's find that out first. Let's do that. What am I looking at? What fraction of the whole lot am I looking for? The probability that y is greater than or equal to 4 is 1 minus the probability that y is less than or equal to 3. We can work that one out the same way we just did the last one. So this is Poisson cumulative distribution for 3. Calculator's already set up to do this one, isn't it? Stick a 3 in there. Calculate that. So we're looking at 0.1767. 1 minus 0.0886. 0.0886. Which means we're really only looking at 0.9114 of the population. Now, it says the probability y is between 2 greater than or equal to 2, less than or equal to 6, but I don't find all of that because we're told y is greater than or equal to 4. So really now what I'm looking for is just how many are either 4 or 5 or 6. That's what we're after, isn't it? So again, I can use my cumulative distribution here. If I find up to and including 6, what the probability is, and calculate that, 0.4688. So here I've got the probability that y is less than or equal to 6 equals 0.4688. Therefore, the probability that y is between 4 and 6 inclusive equals 0.4688. That's the total area up to and including 6, and we've got to subtract that other value that we figured out before, didn't we? The value that was less than or equal to 3. So 0.0886. And what have we got? We've got 0.3802. We can do our conditional probability finally. So therefore, the probability that y is between 2 and 6 inclusive, given that I know y is greater than or equal to 4, is going to be equal to the chance of this happening and that happening at the same time. So 0.3802, that's what fraction of this is also greater than or equal to 4, dividing by all of the numbers greater than or equal to 4, which is 0.9114. And we are going to get our answer. Let's have a go at this one. So, menu, we just want to go to our normal run menu. 0.3802 divided by 0.9114 equals 0.4172. And that would be your answer. One question to go in Poisson now. I got a bit excited halfway through this one, but we've done it now. Catch you in the next one. Bye.